Hello everyone, today we are going to be talking about how to calculate the final velocity if we are only given its mass and its initial height. So for this example we're going to use a skier. Now let's say this stick figure is our skier and he is on top of a hill. So let's just draw the hill like that. Now let's say that we are given that the height of the hill he is on is 25 meters high. And let's say that we're also given, so the height is 25 meters high, let's also say that his mass is 65 kilograms. So first what we're going to do is calculate his initial potential energy using that formula. So you can see here we have the potential energy is equal to his mass times the gravity times his height. So his potential energy is equal to 65 times 9.8 times 25. We can wrap those in parentheses if we want. So his potential energy is actually in the end equal to, if we get our handy dandy calculator here, we know that 65 times 9.8 is equal to 637 times 25 is equal to 15,925 joules. We measure energy in joules. So because of the conservation of energy theorem, we also know now that the initial potential energy plus the initial kinetic energy plus any work done to the object, such as friction, is equal to its final potential energy plus its final kinetic energy. So we know for this example that its initial kinetic energy is equal to 0. So its initial potential energy plus 0, and we're going to assume that there is no force of friction or any additional work done to the object. If we had friction, we would add the force there, but we're going to assume that that is 0. And then we now know that his potential energy at the bottom, since we know that he has no potential energy at the bottom because the height is 0, so that would just cancel out with anything else. So we know that the potential energy at the bottom is 0, and then plus his final kinetic energy. So then we know that his initial potential energy is equal to his final kinetic energy. So we know that his final kinetic energy is equal to his initial potential energy. And we know that the formula for kinetic energy, if we go back to the top, you know that the formula for kinetic energy is 1/2 times the mass times the velocity squared. So if we go back down here, we can add that formula in, and then we can start to solve. So initially, we multiply each side by 2 so that we can get rid of the 1/2. And if we multiply each side by 2, we know that 31,850 is equal to the mass times the velocity squared. Now we know that the mass for this, if I'm going to erase that, we know that the mass for this is 65. Remember, that's a given. So then we're going to divide each side by 65, and we'll know that the velocity squared is equal to 490. So then what we're going to do is we're going to take the square root of each side. And when you take the square root of 490, you get the velocity is equal to about 22.1359 meters per second. So we can actually, only knowing his height at the top, only knowing the skier's height at the top and his mass, we can actually calculate what speed he'll be going at the bottom of the incline. Now, the reason we can do this is because of the conservation of energy theorem. And the conservation of energy theorem states that energy can't be destroyed or converted, or cannot be destroyed or created, it can only be converted. So when we take that into account, we understand that this formula that we went to earlier is true because none of that energy is being just destroyed. We have to account for every piece of energy, and this formula allows us to get the velocity that we got down here. So that's how you calculate the velocity from the initial potential energy.